Let's go through legal number 31. Next permutation. A permutation is an array of integers. Of an array of integers, the arrangement of its membership into a sequence of or into a sequence or linear order. So that means we can change the numbers in the nums array, and just we just keep the same element and the size, but we can change the orders. That is a permutation. And the next permutation of the array is an array of integer is next lexicographical greater permutation with integer. More formally, if all of the permutation of array are sorted in one container according to the lexical order, then the next permutation of this array is the permutation that follows it is sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order. So we'll see for 1, 2, 3, right? The next lexical is 1, 3, 2. This one, right? And 2, 2, 3, 1. Next lexical is 3, 1, 2. In the 2, 1, 2, 3, 2, 1, because this is the largest lexical one. It's already sorted. So the next one will be the smallest one, that is 1, 2, 3, right? So we know for this question, if we have some of the integer which have 6, 5, 4, 3, 2, 1, right? This one is already lexical descending order. So the next one will be 1, 2, 3, 4, 5, 6. And but if we have 5, 6, right? The next lexical one will be 6, 5, something, right? We can use an example. For example, 1, 3, 4. 4, 6, 2, 1, 2, 3, 4, 5. Okay, let's use this example. So how can we compose the next lexical one? We are going to do is that we search from the last digits and search in this direction from the right to the left, and we will see for this part, which is if which were increasing from the right to left, right? So this part is a decreasing order. So when we search, we'll find a 2 will be the first number which has larger number on the right, right? Because we'll see 3 on the right, those kind of numbers are smaller, and 4 on its right, 3, 1 are smaller than 4, right? 6 on its right is 4, 3, 1. It's also smaller than 6. So then we'll see it have this trend and this trend. We'll see 2 will be the first character which have larger number on its right. So this is the first step. Find the number which is the first from right to left, which have large number on the right. If we cannot find such number, that means this integer is in a descending order. Then we just reverse this number to an ascending order, right? So this first step, we find a number which have a larger number into right. The second step is that for these two, we are going to find on its right the last number which is greater than 2. So we'll say 6 is greater than 2, 4 is greater than 2, 3 is greater than 2. So we find 3, right? Find 3. This is the last number on its right, which is greater than this. So this is the second step. Second step, as long as we find such a number on its right, there must have a number greater than these two, right? Because we know this is this kind of trends, right? So there must have a number greater than this. So this is the second step. So what about the third step? Third step is we exchange this 2 and 3. Right, so that will be 5, 3, 6, 4, 2, 1. This is the third step. Third step is that we exchange this number. Okay, so so this is the third step. The fourth step, the last step is that fourth is that we reverse this part. So that will be 5, 3, 1, 2, 4, 6. Okay. So this will be the result. So I don't know. Right. So let's see the expected as we mentioned, right? So from the right to left, find the first one is which have a decrease, right? And in this trend, it's increase and decrease. So we find 2. And the second step is that on these 2 on its right, we find the last number which is greater than 2. So that is 3, right? And the third step is we exchange these 23. So that is 5, 3, 6, 4, 2, 1. Okay. And then the last step is that we reverse this part. Okay. So there are 4 steps. So let's put this 4th step into implementations. So there are two half functions we need to write. One is reverse, another is swap. Okay, I will write those kind of functions. Okay, reverse. For example, in nouns. Let's have a start index and end index. Okay. And we'll also have word called swap. Nouns. And we'll call left and right. So we're going to have these 2 help functions because when we find the second step is that we'll swap, and the last step is that we'll reverse. So let's write the logic. Step 1, from right most to left most. Okay, from right to right to left. Find the first index which has bigger number on its right. Okay, so we are going to use an index. Okay, int index equals let's put this one as -1. So I'm going to have int a equals nums length. So what we're doing to this for int I equals a plus 2 or -2 I greater equal to 0 I plus plus, right? So if nums I which will be smaller than nums I plus 1, right? So in this case, that means we have bigger number on its right. So index I equals I then 3. Okay. So in the end, if we cannot find out, right? So that means if index equals this, right? Means with every number is in a descending order. Then we just call the help function reverse, right? Reverse nums 0 and -1. Okay. So we find this is the first step. The second step, step 2, from this index, find the last index, which index number, okay, greater than nums index, okay, greater than num index. So we know, so this one, it will always have results. Here, if this one, we should have a return, right? Because we don't need to do the step 2 for this kind of scenario. From this index, find the last number greater than this index. So what we are going to do is that we have we call int last index. Okay, last index equals index +1, right? So that means at least as long as we have this condition, index +1 will always be greater than the index, right? So we can do for int j equals last index is smaller than n j plus plus. If nums j greater than nums index, so we have last index of j, right? So in this case, we don't need to break because we need to find the last one, right? And step 3, swap in index and the last index. Okay. So nums, right? So this is what to our help function. So that would be swap nums index last index. So step 4 is that we reverse the from index plus 1 to the end. So that is reverse nums index plus 1 to n minus 1. Okay? So that will be our steps. Let's write those kind of help functions. So reverse is that we use a while loop, right? While start smaller than end. So I have we already have a swap, right? Swap, you can press swap first. Swap that is intent equals nums left, and the nums left equals nums right. Nums right equals 10. This is the swap, and then swap nums start and we'll have a start plus and nums. Okay. ENT. Line 6. A minus 2 I greater if the nums 6 out of less 6. 6 nums into I minus minus. Not nice. Okay, so this is the ON time complexity for the because we just iterate, right, in the swap once, and a reverse just a reverse once, right, here or here.